Now, port numbers in networking. What is a port number? A port number is a 16-bit numeric value that identifies a specific process or service running on a device. It works alongside an IP address to ensure data is delivered to the correct application. Think of it like an apartment number in a building. So the building address is your IP address, while the apartment number is a port number. So now let me explain it this way. For instance, now, we said when you communicate over the internet, you make use of your IP address, you make use of your MAC address, then you make use of port numbers. Now, if, for instance, now, let's say you are living in an apartment or you are sending a package to somebody living in an apartment. Now, assuming that apartment has about, let's say, 10 rooms or 10 different spaces inside the apartment. Now, you send the package to the apartment. When you give the address to whoever is sending your package, you give the address of the building. When the person gets to the building, now the person needs the address of the specific room that he or she is also going to. That is where port number comes in. So the address of the building is the IP address of the recipient. Now it now needs a specific address to tell it, okay, this is the application you are going to, or this is where you're actually going to. So what do I mean by this? For instance, now when you communicate over the internet, you use, if it's a secure website, if it's an HTTPS website, you use port 443. Now, what this port helps you do is that if, for instance, if you send a message to someone now on WhatsApp, if you send a message to somebody on WhatsApp, how does the IP address of the recipient know that it is going through WhatsApp or it is going through this particular protocol? It is the use of port number. That's it. Because imagine you just send a message to a system. There are so many applications on that system. There are so many softwares on that system. So it needs a particular direction for it to know, okay, this is the particular route I am going to take, or this is the particular place I am going to. So that is where port numbers come in. So we have range of port numbers. So port numbers ranges from 0 to 65,535. It's a 16-bit number. Now it is divided into 3 categories. Now the first category is the well-known ports, which is from 0 to 1023. Now these port numbers are assigned and managed by IANA, which is Internet Assigned Numbers Authority. They're the ones that manage these specific port numbers, especially the one from 0 to 1023. Now, examples of port numbers that fall within this range, we have FTP, which means File Transfer Protocol. So most times when you're downloading a movie from a website, since they don't need the movie to be secured because there's nothing they're hiding there, most times they make use of FTP, which is File Transfer Protocol. That is what they make use of when you're downloading a file when you're downloading any file online. You are using a protocol called FTP. Then we have SSH, which means Secure Shell. Now, Secure Shell is an encrypted tunnel to actually communicate over a network. That is port 22. So we have SMTP, which is, I think, Simple Message Transfer Protocol. This is what your email uses. So that is port 25. Then we have DNS, which is port 53. I explained DNS, which is Domain Name System. That translates domain names into IP addresses for the system to understand. It uses port 53. Then we have HTTP, which is Hypertext Transfer Protocol, uses port 80. We have IMAP, uses port 143. IMAP is also used by your email. Then we have port 443, which is HTTPS. That is Hypertext Transfer Protocol secured. That is the secured version of port 80. So these are some ports that fall within the range of 0 to 1023. There are still other ports that fall within that range. I think we have Telnet. I think Telnet uses port 23. I think we have Telnet. Then there are some other ports like that. So the second category is what we call registered ports. Now these ports fall between the range of 1024 to 49,151. So they are assigned to specific services or applications by vendors. For instance, my SQL uses port 3306. We have RDP, which is Remote Desktop Protocol. That one uses port 3389. Then we have AT80. AT80 is an alternative for HTTP. So these are registered ports that fall within that range. Then we have the dynamic or private ports. Now this falls within the range of 49,152 to 65,535. So it is used temporarily by client devices when connecting to servers. So your own device now, for instance, if your own device wants to communicate with the internet, your device uses any dynamic IP address within the range of 49,152 to 65,000. Automatically, it chooses. I would show you how you can actually check. I'll show you something like that, how you can see what I mean by that. So automatically, it chooses a particular port number to communicate with the port number that you are going to. So if you are visiting an HTTP site, which uses port 80, your own device selects a port range within the dynamic port to communicate with that port 80. Do you get that? So examples is, for instance, they say when visiting HTTPS, when visiting google.com, your browser may open a random port like 49,543 to communicate with Google's server on port 443. And for port 443 is HTTPS. Do you get it? That is how port numbers actually work. So we have TCP versus UDP ports. So we have TCP. TCP is Transmission Control Protocol. Now it is reliable, connection-oriented, error-checked. So examples of services under TCP, we have HTTP, we have HTTPS, we have SMTP, and we have FTP, which is port 21. Then we have UDP. UDP is User Datagram Protocol. It's fast, connectionless, no guarantee of delivery. Example of services, we have DNS, we have DHCP, we have various ports, especially for online gaming. Now, what is the difference between TCP and UDP? Now, TCP is Transmission Control Protocol. Now, the difference is that when you are using TCP or when TCP is in motion, what happens is that there's something we call a three-way handshake. Now, a three-way handshake first occurs in the sense that let's assume you want to visit google.com now. If I type in google.com, now what happens in the backend is that the DNS, which is port 53, translates that domain name into an IP address, into Google's IP address. Now, my own device public IP now goes to look for Google's IP address. The moment of it looking for Google's IP address, we call it SYN request, SYN request. So my IP address sends a SYN request to Google's IP address. Now Google's IP address now responds to my IP address with something we call SYN and ACK. That is SYN and acknowledgement. That is the second handshake. So the first handshake is what do you call it? The SYN request. Then the second handshake is when it responds with a SYN and ACK. Then my own IP address will now do the last handshake to say, okay, we can actually start sending details. That is, I've acknowledged that you are actually google.com. That is the third handshake. Now, the reason why I'm explaining this is that TCP actually makes sure that your data reaches its destination. It reaches its destination. That is, when the three-way handshake has occurred, if you send a request or if you upload a document, if you realize that if the document doesn't go through or if what you're uploading doesn't go through, it bounces back to make you realize that it is not working and you can try it again. That is for TCP, but it is slow. It is not as fast as UDP. But UDP is user datagram protocol. Now, UDP is very fast, but UDP doesn't care if your data actually reach its destination. Its own is just that it is bombarding your SYN request onto the place you're actually sending it to. So most times UDP is usually used in gaming, or for instance, now this video calling we are using, because it needs fast, it needs to be fast, it needs speed other than reliability. That is, it needs to be sending my packets very fast so that it will get to its destination and it can tally, the voice can actually tally with the video. But if it says it should use TCP, then there will be issues, there will be errors, or there will be hanging in the video recording that we actually have. So if I should check my system now, you realize that the protocol we're actually using on this call is under UDP. Do you get that? So that's the difference between TCP and UDP. Then next one, we have the OSI model, or the TCP and the TCP/IP models. Now, why models? They help standardize how devices communicate. Now, this OSI model was created to make sure it is the communication between different devices or different applications are actually standardized and broken down in different layers. Now, these layers, when as a network engineer, it is actually these layers that network engineers use to troubleshoot. So at every layer, they should be able to understand what the problem is. For instance, if they check the first layer, they realize, okay, the problem is not for the first layer. So most times, network engineers communicate with layers, especially when it has to come with OSI model. So the first layer we have is the physical layer. Now, the physical layer has to do with cables, switches. That is, the moment you are putting your RJ47 cable into your system, or you are using internet cable, once you are just connecting cables to the process of connecting cables to your switches falls under, when anything that has to do with cable connection, whether wireless connection or cable connection, falls under physical layer. So if they are troubleshooting and they check the cables, they realize that the cables are actually well connected, then that means the issue is not from the first layer, which is the physical layer. Then they move to the second layer. Now, the second layer is data link layer. Now, this is where MAC address and your internet comes in. That is, this is where your data, transmission of data starts in bits and bytes. You understand? So this is where devices now understand the MAC address. Okay, who owns this MAC address? Who owns this MAC address? This happens under data link layer. Then we have the network layer. So this layer has to do with IP addressing and routing of traffic. So this is layer where when your device starts, for instance, I was explaining something that if you put on hotspot on your phone, your device has to assign private IPs to the devices that are trying to connect. So the process of them assigning private IPs using a protocol called DHCP. Now, DHCP is Dynamic Host Control Protocol. So when they use that protocol, that process falls under network layer. So probably when they are troubleshooting and they realize that a particular IP address is not communicating with a particular IP address, then they would check where the issue is under the network layer. Then we have the transport layer. This is where it now decides which protocol it wants to use to communicate over that network. So whether to decide to use TCP, which falls under HTTP, HTTPS, or to use UDP, which means it needs speed. It is under the transport layer, it decides this. Then we have the session layer. Now, this layer manages session. So what do they mean by session? For instance, probably you log into your bank account. If you log into your bank account, you would notice that when you leave your application or your website idle for a particular period of time, it logs you out. Now, that means that session has ended. So the moment you are still active together with the server, your communication with the server is still active. That is, you can still operate your application, you can operate your network, or you can operate your bank application at that time. That means that session is actually open. That means that session is open, which means you can still communicate between you and the server. So that is the session layer. Now, session layer uses something we call session ID. Now, hackers actually use session ID to hack into website. That is why they put a timestamp on your session, whereby if your session is idle for a long period of time, automatically, according to the code or the code they've actually set to that website or application, it logs you out so that an hacker doesn't take advantage of that, because an hacker could actually use your session ID to log in that same account into another device if it wasn't well, because there are other mitigations against that. If it wasn't well structured, it could actually happen. Then we have the presentation layer. This is when data encryption occurs, whether your file is in zip file or your file is in PDF format, or your file is in Word format, or your file is in image format. It is at the presentation layer you get to know that. Then the application layer now has to do with what you are using to view the software. Let's say the software that you are using to view that information that is being passed across. That is where the application layer comes in. Now, as for me, the code I actually used to remember the OSI model, I use please do not throw spoiled pizza away. So that is PDNTSPA. That is what I make use of. So you could come up with your own, because the OSI model is actually very important, especially in networking. You need to be able to understand how data or how messages or how packets actually move. Now, the TCP IP model is just a summary of the OSI model. It's just a summary of the OSI model. So we have the network interface. Now, the network interface has to do with the physical, the data, and the network in one. So the physical and the data link, that is the network interface. Then the internet is the network in the OSI model. Then the transport is both transport, I think both transport and session, while the application layer is the presentation and the application. So you just use that to understand the TCP model. Now, there's something we call encapsulation. Now, encapsulation is a process whereby your message goes all the way from physical to application. Then the encapsulation is the process whereby the message goes from application, reverses itself back to physical. What do I mean by this? You open your WhatsApp now. You text hello to somebody. Let's say, okay, let's assume it's a connected network now. Maybe it's a wired network. Let's use a wired network. Let's not use wireless. So in a wired network, let's say in an organization now, all the devices are connected. Now, probably the software you are using, or let's say maybe you are using Google or you are using Teams. Now, you send a file to a device. Now, the moment you send a file, you started from your application where you can see what you are sending. It moves all the way to presentation. Okay, it is PDF that you are sending, right? It moves over to presentation. Then your session is open to connect. Then it moves to transport, network, data, and goes through the cables. Now, immediately it gets to the person that you're sending it to, this process now reverses. From your own end, you started with application, what you can see. Then the others, you might not be able to see them, how it's happening. So it goes. So the moment it gets to the person's device, it reverses this case. That is from cable to data link to network to transport. Then the person will be able to see what you actually sent. So that is just a simple analogy of the OSI TCP model. Now we move to network security. We've talked about networking, how devices can actually communicate. So now we move to network security. Now, what is network security? Network security is a set of practices, technologies, and processes designed to protect networks, devices, and data from unauthorized access, misuse, or cyber attacks. So the practices and technologies or the processes that you actually use to secure your network is known as network security. Okay, now you built a network for an organization. Okay, computer can communicate with this computer, can communicate with this device, can communicate with printer, can communicate with your IoT of things. I told you IoT of things are devices like printer that can communicate with the internet, your camera, there are smart refrigerators too, there are smart doors. All those things are known as IoT of things, especially when they can connect, communicate, or they can be connected to a network. Now you've designed everything now. So how are you able to make sure that this network is actually secure? That is where network security now comes in, because an hacker can hack you through your camera. So far, it is connected and it has its own IP address, because a camera that is an IoT of thing, which is a camera that is connected to your network, has its own IP address, because without its IP address, it will not be able to communicate to the other devices that it's working with. So an hacker could actually hack you through your camera if your network is not properly secured. So now we have the CIA triad of security: confidentiality, integrity, and availability. I think I explained this once before. That is, as cybersecurity personnel, you need to understand your whole existence. Your whole existence has to actually do with the CIA triad, which is confidentiality. The C stands for confidentiality. That is, ensuring only authorized people have access to a particular data. So that means the person that must have access to this particular data must actually be authorized. The person must actually have the right for that data. If not, the data should not be accessible to that person. Then we have integrity, ensuring data is not altered or corrupted. I showed you hashing. That is how you can know if a data's integrity has not been tampered with. So for instance, if you hash your file and you save your hashes, if you go back to that file, or when you send the file to someone and you also send the hash to the person, if the person hashes the file and doesn't get the same exact strings that you generated when you hashed the file, then that means that file has been tampered with, which means the integrity of that file has been damaged or has been tampered with. Then we have availability. That is ensuring systems and services are accessible when needed. So even if you are trying to protect a file, protect data, they should also be available when needed. You understand? So whether it's you're trying to make sure, okay, this person cannot have access to this data, this person cannot, no matter what you are trying to protect, data should still, you must have a way of making sure they are available when needed. So that is the CIA triad. Then we have the business relevance. So it helps prevent financial loss. It protects the brand reputation, meets legal and compliance requirements. I guess you were taught, yeah, I think I was in that class. So you were taught about GDPR and the HIPAA frameworks and the guidelines. So one thing about network security, it prevents financial loss, because if your network gets hacked, you could actually lose money. because of that, depending on what was destroyed or what was taken from you when your network was hacked. Then protect brand reputation. If in an organization that saves people's data and you discover that your organization has been hacked recently, then your brand, you will not believe in that brand anymore. So it will not you will not be able to protect your brand reputation if your network is not secure. Then also meets legal and compliance requirements. So according to these frameworks, there are some requirements that the organization is supposed to meet up with to show that customers or your clients' data are actually secured. Then we have common network threats. So what are the threats that networks actually receive? What are the threats or what are the ways that could actually damage your network? So the first one, we have malware. So under malware, we have viruses. Now they attach themselves to files and spread. We have worms. Worms self-replicate across networks. So one thing, the difference between worms and viruses is that for a virus, you actually need to interact with it. Probably you open a file or you open something for the virus to spread. But for worms, even if you don't interact with it, immediately it enters your network like this, it just starts to spread. Then we have Trojan horse. It's called Trojan horse. That is malicious code disguised as legitimate software. So there are some times that you download an application. The application is meant for something else. Meanwhile, the application is actually doing another thing in disguise. And where this is gotten from, in those days, there's this kind of wooden Trojan that soldiers actually they actually build, whereby they would gift it to a king, saying, okay, this is what we have for the king, not knowing that the enemy soldiers are actually hiding inside that wooden horse. So that is where they actually got the name Trojan horse. So when a software that is probably you downloaded a software now that is supposed to be a game, at the end of the day, after downloading, you don't know that the software is actually doing something else in your device or in your network. That is why there are people that work on application security, whereby before your organization can actually make use of that application, they have to scrutinize, check the code, check everything, and make sure that there's nothing embedded in it that could actually cause harm to your organization or your network. We have ransomware. We have different types of malwares that could actually we have keyloggers. Now, keylogger is a type of malware that actually saves your keystrokes. So if you are infected by a keylogger, what keylogger does is that any stroke you are typing on your system, anything you are typing on your system, it saves it to the threat actor's device. That is what a keylogger is all about. We have spyware. That one spies on what you are doing on your system. It just spies and reports back to, depending on what the hacker has actually set. So now we have denial of service and distributed denial of service. Now this overwhelms systems with traffic. I think I once explained this too. So denial of service has to do with a situation whereby, I explained the three-way handshake just now, whereby you visit a website. When you are visiting the website, you are sending a SYN request. Now, all websites actually have the number of SYN requests they can actually handle at a particular point in time. Now, imagine you are now sending a single person. When you a single person visits, it is just your one SYN request that you are sending. Now, imagine as a single person, you are sending about 1 million SYN requests in a second. There are tools to actually do that. That's what we call denial of service attack. Is what usually used on websites so that you make the website either manage the website or make it slow. Example, I placed an example, for instance, maybe in your school, or maybe they said by so time everybody should go to this website and claim a particular prize. You realize that when you go to the website, is either your phone cannot access it or your device cannot access the website, or the website is actually very slow. This is because the number of people that are actually visiting that website at that particular time, that are sending SYN requests at that particular time, are more than what the website server can actually handle. So now what is now DDoS? Now DDoS is when multiple different people are now sending millions of requests, of SYN requests at a particular time. This could also be done by a single person, whereby the hacker has employed different devices. And how can an hacker employ different devices to send requests? It could be through phishing attack, through phishing mail. Whereby once you click on the link, you will not know that your device has been employed as a bot. We call them bots. The moment an hacker is controlling your device to send requests, your device is now a bot at that particular time. So that is the difference between denial of service and distributed denial of service. One of the ways they actually mitigate against it, maybe you are visiting a website, you could see Cloudflare, that is to actually confirm you are not a robot, or you see click this image, identify a crosswalk or a crossway in this image. Those are some of the ways they actually use to mitigate against DDoS or DOS attack. Then we have phishing and social engineering. Now, trick users into revealing sensitive information. So phishing mail, when an hacker or an attacker or a threat actor sends a mail telling you to click a particular link, that is what we call a phishing mail. Now, phishing has different types. We have phishing with the V. That is when it comes through voice call. When they're trying to trick you through voice call, it's called phishing. When it comes through text messages, it is called smishing. When it comes to text message, it is called smishing. Now, when there's also something we call spear phishing. Now, spear phishing is a situation whereby an hacker or a threat actor actually has a target, probably a particular person in that organization that he actually wants to send the phishing link to. So what will the person do in his reconnaissance stage, whereby it's trying to gather information? He would probably visit the target's website, visit the social media pages to know what the target's interest is actually all about. So let's say as a lady that likes bags, she likes to post about different bags on her social media pages. Now an hacker, okay, has seen that, okay, it seems this my target likes bags, then he will try and design a phishing mail that has to do with you requesting for a cheaper bag. Probably might send a mail to you that there's this so bag. Probably you've always, maybe as a lady now, you've been posting, maybe somebody should buy this bag for me. I wish I could get this bag, something like that. Now, an attacker could actually use that against you and send you a phishing mail to actually trick you to click a particular link. There was one message I was reading that it's like just like a joke, where the guy posted and said something like causing trouble. Everybody's running around in the office, me sitting in one corner that actually clicked the link that says get iPhone 17 for free. You know, things like that now. And he actually clicked the link, and the link has caused trouble in the organization, but he's on his own. Everybody's running up and down. What is happening? Trying to investigate. Do you understand? So that is what we call spear phishing. Then we have whaling. Whaling is where the target is actually a big fish in the organization, or probably somebody in the admin level. That is what we call whaling. So social engineering is just using different tricks to try and trick you. So phishing falls under social engineering, because phishing is also a way to just trick you to make sure you release your details or to do what they want. For instance, you could actually maybe receive a call. There are some of us that have experienced this. Receive a call and somebody will tell you that I'm from your bank. Drop your they will send you an OTP just now. So you send it to us. That is an example of social engineering, trying to trick your clients or your targets to actually drop some informations. And as cybersecurity personnel, you need to understand something. There are so many tools out there that somebody could actually use to get your information through just your phone number. So don't be fooled when somebody calls you and the person is telling you your details, probably details that you don't even know you've put out there before, and the person is telling you your details, or the person is giving you some in-depth information about you. Now, your phone number carries a lot of your phone number, your email address carries lots of information about you that could actually be used as an investigation towards you. Now, some of those tools are free, some of them are paid tools. You understand? They are called reconnaissance tools. So those tools, they could actually use to get information about you. So when somebody is calling you, telling you your house address, telling you your dad's name, your mom, all those things, and you think, okay, this person seems legit because he knows all this information. That is not true. You have to always double check. For instance, now in organizations, when you receive a call as a cybersecurity personnel, the training we give to organizations is that when you receive a call that is supposedly supposed to be from your boss, so far it has to do with relieving or giving out sensitive information, make sure you double check to make sure it is actually, because AI now has made things very, very difficult for people to even know the difference. They can even mimic your boss voice. They can mimic your voice, your boss face. Now, a lot of things can actually happen. So we always train them to always make sure you double check. Make sure it is your boss that is giving this information. Then we have man in the middle attack. So it intercepts communication between two parties. I think I actually showed you guys what a man in the middle attack. An example. There are so many there are varieties of man in the middle attack, but that was just one. When it's an HTTP website whereby an attacker can actually intercept your traffic, copy out what you are trying to post, or even change what you are trying to do. That is a man in the middle attack. Then we have packet sniffing and eavesdropping. Now, packet sniffing is a situation whereby an attacker is trying to eavesdrop on your network communications. That is, how your network is communicating, all the details between your networks. The attacker is trying to eavesdrop on those communications. We call it packet sniffing, whereby you're trying to listen on that network. They call it listening. You're trying to listen on that network to know what the communications are all about. Then we have authorized access, that is exploiting weak passwords or misconfiguration. That is when you set a weak password to your network or your device. All those kind of things are common threats or common network threats. That's why we always advise you have a strong password. Do not use the same password you use for account A for account B. It is very risky. Then the next one is zero-day attacks, exploiting vulnerabilities before patches are available. So the simple definition is when an attacker is exploiting a vulnerability that even the owners of the software do not know about. That is why most organizations always perform what we call bug bounties, whereby they put their network out there or put their website out there and employ hackers to try and hack them and see where they're vulnerable. You understand? I think there was a time Apple was boasting of I think about $1 million or $1 billion for any hacker that could actually hack their latest iOS. So that's what we call bug bounties. So they try and do that most times to make sure that they are not victims of zero-day attacks, because hackers are not sleeping. They always find new ways to make sure that they get into your system. That is why sometimes WhatsApp will just update for no reason, tell you must update. And if you check on your Play Store, if you check the reason why they're updating, they will tell you that a bug has been discovered, or they discover bugs most times. That's why they are patching. So those are what we call patches. That is why we also advise organizations, any software you are using, make sure it is up to date. Do not use cracked versions. For those of you that are using cracked Office, cracked Microsoft Word, cracked, the day an hacker will have your time, you would understand why it is very necessary to make sure you are using the right softwares and updated software. So we have common security, network security controls. So one of the common security controls is firewalls. Now, firewalls block and allow traffic based on rules. So we use firewalls to block traffic based on the rules you actually set to it. So we have antivirus and anti-malware softwares too. So we have antiviruses whereby they try to protect your device from malicious softwares. Then we have IDS and IPS. Now we have intrusion detection system and intrusion prevention system. So intrusion detection system helps to detect malicious activities in your network depending on how you set it up. Example of an IDS is SNOT, SNORT. If you check online, you see SNOT. Now, SNOT is a software that you can is a kind of software that you could actually put on your network or install your network to try and detect malicious traffic in your network. So we have two types of IDS and IPS. We have the host-based, whereby you have to install it on all the devices because it is host-based. We have the network-based, whereby once you just install it on your network, any device that is connected to that network is actually bound to that IDS. Same thing goes for IPS. We have the host-based and we have the network-based. So we also have SIEM, which is Security Information and Event Management. Now, this is a centralized login, monitoring, and alerting. Example, we have Splunk, we have ELK, we have QRadar. Now, all these are what we call event managers, that is log managers, whereby once you install them on your system, it takes logs, it saves logs of everything that is happening on your network. If a worker should log in, it will save the log, the time the person logged in. Maybe the person puts in a wrong password. Why the password was wrong, this log actually saves everything. It sends a particular file to so and so device. It saves that IP address. It sends this one. Everything you do on that network to the last bit on that network, SIEM tools actually save all those things. That is what we call SIEM tools. So they save logs because it is useful for investigation and is also useful for what we call IOC, which is indicator of compromise, for you to know if an attacker is trying to gain access into your network. Imagine an employee that is supposed to log in to work by 8 a.m. And when you are checking the SIEM or you are checking the logs, you discover that there's somebody trying to log in the device at 12 a.m. Using that same worker's identity. Now, it could be the worker, which could actually be something we call an insider threat. Probably the worker don't even mean the organization itself. Do you understand? So just trying to get back an organization and trying to do some kind of cunning things on that network, or could be an hacker trying to gain access to. So this monitoring of logs actually falls under the work of SOC analysts. So that is why most times SOC analysts' role is always shift, because they have to always monitor network 24/7, because no matter the intelligence tools that you actually set, they could actually be bypassed by hackers. So we have network scanners. So example, we have Nmap, we have OpenVAS. OpenVAS is for vulnerability scanning. Nmap is for network scanning. That is, it also helps you to scan. I will show you how Nmap works. It helps you to scan the what do you call it? The ports that are actually open on. Yeah, that reminds me, sorry. About ports, I did not say there are different levels, or we like call it stages of ports. We have open ports, we have closed ports, and we have, I think, inactive. I'm not really easily getting the term. It might not be inactive, but something that is not open and not closed. You should understand what I mean by that. So an open port means that port is actually open on your network, be it port 80, because for instance, on your device, if you close port 80 on your device, you will not be able to visit any HTTP site. Maybe if time permits us, I can show you that on the firewall, how you can block ports. If I block port 80, I will not be able to visit any HTTP site on my device. Same thing, if I block port 443, I will not be able to visit any HTTPS. It will even log out this call because this call is using HTTPS, which is secured. It will even log us out. Do you understand? So that is what we call open port and closed port. So when a port is open, that is, it can communicate. When a port is closed, that is, it cannot communicate. Then when it is not open or it is not closed, that is, it is open, but it has set rules to actually filter out unnecessary port traffic. Do you understand? So those are the 3 stages of ports. So the reason why I said that is when we use Nmap to check it, you'll be able to know, okay, on this particular network, on this particular IP address, the port is closed, it is open, or it is inactive, or what's the last one? Yeah, so the next one is packet analyzers. So monitor and analyze traffic. Example, we have Wireshark and we have TCPDump. If time permits, I would actually show you that too. So Wireshark is what we use to analyze packets. That is how you know how packets are moving on a network. Then we have VPNs, which is virtual private networks. Now, this helps to encrypt remote connections. So when you are making use of a VPN, that is, your packets will now be routing through another tunnel or another address to show that you are not using your own IP address. Then we have password managers and multi-factor authentication tools. So this also helps you to secure password managers. For those of you that use Google password managers to save your passwords, then we have multi-factor authentication tools that like the Google Authenticator app. We have the Microsoft Authenticator app, whereby you set it to make sure that even if you log in, you have to use your application to authenticate. So those are authentication tools. Then we have encryption tools. We have TLS and SSL. I think TLS is transport layer security. Now, this is the encryption method that HTTPS uses. So HTTPS, the secure, uses TLS and SSL. I think SSL, is secure shell layer, something like that, for your web. Then we have IPsec. Example of IP security is VPN. So we have SSH for secure remote access. Good. Next one. So best practices for network security. So use strong authentication. So complex and unique password. Use multi-factor authentication. Then patch updates regularly. Make sure you don't leave your softwares out of date. Then secure network devices. Change default usernames and passwords. Disable used services and unused services and ports. That is, there are some ports in your network that if you are not making use of, they are not supposed to be open so that they don't get exploited by hackers. Then use firewall and access control lists. So we have firewalls, we have ACLs. You can actually use that to filter out traffic. Then we have encrypt data. So do data encryption later to see how you can actually encrypt your data. So if you are using a website, make sure your website is HTTPS. That is, you purchase a secure certificate. That is a certificate to show that your website is secure, or you could build one yourself because most of these websites actually build. That's the example of what there's somebody that raised that question that in their company's organization, in the back end, he or she sees HTTP, but when they visit the website, it is HTTPS. That is because the certificate was built by the person that actually built the website or a security personnel in the organization. So we have monitor and log activities. So you make use of SIM tools. Then we have backup data regularly. So both offsite and on cloud backups. Always make sure you back up your data in case of a ransomware attack, because most times you advise organizations, if you experience a ransomware attack, do not pay the ransom, because there's no assurance that after paying the ransom, they would actually release your data for you. So it is better you have backups, both on-site, off-site, where you are testing regularly to make sure that those backups are not corrupt. Even you on your own system to ensure maybe any day your system crashes, you don't lose everything. Make sure you back up. If you have an external hard drive or you have a flash drive, try and back up your data and make sure you are testing your backup regularly to make sure it is not yet corrupt. Then educate users. Security awareness is very important because most times it is end users that actually fall prey of most of these network attacks. So it is very important that you educate users. Then implement network segmentation. So like I showed you on Packet Tracer, network segmentation is just the calculation that we did. The calculations that we did to ensure that this network is for this range. Once it is going outside that network, then it needs a gateway to communicate. And if this network is has been attacked, then I can shut off the gateway to make sure that it doesn't jump into the other network, because there's something we call VLAN hopping. VLAN hopping is a method an attacker uses to hop from one network to another network. So once the network has been shut off, you will not be able to hop into that network. So we have VLANs. Now VLAN, the segmentation we did, we used different switches to segment the network. That is, switch one, we set a network range on this switch. Switch two, we set another network range on this switch. Now that is VLAN segmentation with switches. You understand? There is also VLAN segmentation whereby just with one switch, we use two switches to set two networks. Now, just with one switch, you could actually set up a segmented network. Maybe for an organization that doesn't have money to buy plenty switches, maybe they have like 10 departments and you have to buy 10 switches for 10 departments just because you want to segment a network. So as a security engineer or a network engineer or a network security engineer, you could actually use your configuration to minimize the amount of switches that would be used. The configuration is a little bit more complex than the one we did. The one we did is still a little bit simple, whereby just have this switch, make sure your calculation is right, your IP address doesn't fall off from the range, then you are good to go. So that's what we call VLAN. So VLAN is virtual land area network. So when you're trying to create area networks virtually to separate networks, that is VLAN. Then we have incident response plan. So organizations actually have something we call incident response plan. Probably when we get there, we'll talk about it. So incident response plan is a situation whereby for different kind of attacks that have occurred, they have a ready-made plan to be able to get themselves out of that situation fast enough. For instance, if you go online and check incident response plan for a DOS attack, you would see different steps on how to get yourself and investigate out of that attack to make sure that your company gets back into operation as early as possible. Now, they also create incident response plan for future incidents that they can just foresee. For instance, now in countries that do have hurricane or do have earthquake, they could actually foresee, okay, if we are hit by an earthquake, how do we actually bring ourselves out? How do we make sure that our business continues, which is the business continuity plan? Then our network or our IT or our technologies continue. That is DRP, which is disaster recovery plan. So all these things are set inside an incident response plan. That is what we have. Let's now go into some practicals. So the first one, let me show you. I think let's first work with this one. Sorry, I'm trying to set up something. Sorry. think the first one we should do is let's use Nmap to check the. So I want to set up this thing first to check so that we can check. This is like a website for you to perform penetration testing on websites. And I think there was inside we talked about let me see. We talked about look back address and local host. So I will show you what a local host and a look back address. We talked about 127.0.0.1 to the range of 127.0.0.255. So the reason why it is set out for a look back, that is when you want to communicate back with your device, you don't want it to go outside your network. That is when they make use of a loop back address or local host IP. So I'll show you how that works now. Sorry, I'm not supposed to take time like this. All right, so you can see what I use now. I make use of 127.0.0.1. So that is the loop back address. That is this website I'm using now. I'm trying to communicate back with my computer. So this is one of the websites that is actually used for website penetration testing when you want to practice. So okay, so what else can we do? I mean, let's use two different things. Let me also use this one also. Use this one. This is Metasploitable. It's also used for website hacking and network hacking also. So it's used to test how network hacking actually works. So I just want to use this for something. I want to use the website aspect of it. So 192.168.183.129. Okay, so this is as in what now? I can't start troubleshooting this one now. So we'll make use of this one. So let's try to see. So let's try to see. Um, So the first one I want to use is nmap. So let me check some things in the nmap first. Let's see. I want to check the commands that I'll be using. Let me just try. So now you will see what it gave me now when I try to check the ports that are open on this. You will see TCP port 22, which is SSH. You see that the states, the state I wanted to remember. So states, we have open, we have closed, and we have the third one. So port 82 is opened under here. If you see port 33062 is open. So assuming this is an IP address on your network, and you actually check and you discover that this is open. Now it means if it is a public IP address, let's try and check for a public IP address. So let's look for. I don't want to use a non domain name. So let's use example.com. So let's first check for IP address of this. Okay. So this is a public IP now. So now let us check. Let us check the ports that are opened here now. So as you can see, when we check this, notice the public IP, right? So when we check this public IP, we discover that port 80 is open, port 443 is also open. That means if I try to communicate with port 80 on this domain, which is example.com, then I'll be able to have access using port 80. You get that, right? So in this kind of, to make sure this is secure, now the reason why port 80 is open, probably because it is an HTTP site. That is why port 80 is open, or they have an HTTP part of their site. That is why it's open. But if they are not using it, it would have actually been advisable that they actually close down these ports. Same thing goes for your devices. You could actually close down ports on your device. So that is for nmap. Then the next one has to do with Wireshark and TCPDump, right? So where we can actually check how networks are communicating. So let me open my Wireshark. So let me start my traffic. Let me start my traffic. And let's go and visit different websites, browser. So we have this open. This is one thing. Let us visit facebook.com. I think this is the only one we'll actually be making use of now. Let's just make use of this. So let me say, so let's just say I'm trying to log in this. I try to log in this. Let me visit something else. So, come like this. I think these only sites will make it up. But I'm just trying to have different. Okay, let me do this too. I'm just trying to have different things working on my network. Let me check. What was that? Let us ping google.com. Fine. Example.com. If they flag me. Right. So let's go to our Wireshark now. Can you see it is actually running different packets? So now this is what happens in the backend when you're trying to do anything over a network. You understand? So if I try to filter this, and now if you see this source now, this source is saying the IP address that tried to communicate is the IP address that tried to communicate, then this is the destination. Now, this IP address, if you look at this IP address now, you notice this is the IP address of that Metasploit table that I opened. Now, I use it to ping example.com. Now, I'm trying to check if example.com is active. Now, this is the IP address of example.com. Now, it's made use of, let me check the ports down here. Now you see it's made use of ports. This particular one I click now made use of ports on my device. It's made use of ports 39083. Now the destination port, this is when it was trying to translate example.com into an IP address. You see it was using port 53, which is DNS. Do you understand that? So immediately after it communicated or it did the first handshake, it will now start doing other things. You can see different protocols. We have TCP, we have DNS, we have ICMP, and different protocols like that. So this is how devices communicate over a network. If I was able to visit facebook.com, if I search for Facebook now, you would have seen what happened when I tried to visit facebook.com. You guys understand that?
Yeah.
So now back to Wireshark now. Don't worry, we will still do Wireshark later. Back to Wireshark now. So let me follow this now. Let me say I follow stream. So now these are the packets that were communicated at this period. Now, because the site I visited is encrypted, that is why all these things seem as if it is jargons. But these are packets. Do you understand?
Is encrypted.
But if it was to be an HTTP site, everything will be written in plain text. That is the difference.
All right.
You understand? If it's WhatsApp, that's why they tell you that WhatsApp is end-to-end encryption, because even if packet sniffing happens, this is what the person sniffing will be seeing. Encryption. You understand? So even if you send a file, if you send an image, everything is going to be encrypted. But if it is, and if there's no time to show you that, if it's an HTTP site I visited now, and everything I put there, if I capture the traffic like this, it will all be written in plain text. Whether I sent documents, I will be able to open the document. I'll be able to see the file here. Do you understand? Because it will all be in plain text. You get that? So these are packets. So these are packets moving. These are packets.
So all these number, time, source, destination, protocol. So how are you able to get, is it that you are connected to a particular Wi-Fi, or I'm just trying to understand how you get the all
So the
this
way Wireshark works is that Wireshark captures traffic of everything happening on your network. So any network, any device that is connected to that network, it will be able to capture all the traffic on that network. So anything you're doing on that network that has to do with the network, do you understand? It will be able to capture everything. So this time means the time that particular thing actually took place. This IP address means the IP address that made the request at this particular time. This
Okay.
destination means the IP address this IP made a request to. You understand? If you can look at it
Okay.
now, you see this is TCP, right?
Yeah.
This is TCP. That is, they're trying to perform handshake here. If you look at this place, okay, this is an acknowledgement. You can see an arc here, right? So that means they had already performed the three-way handshake. So they have acknowledged. So let's go to where the SYN request was actually sent. Okay, if you look up here now, you see SYN, right? Now, this was when the request was sent. If you look up here, this is when this IP address sent a request. You know, this is a private IP, right? This is
Yeah.
the private IP of, I think, the other um, website I opened. This is the private IP. This is
Okay.
my private IP, sorry. So private IP
Okay.
tried to make requests to this public IP, right?
Okay.
That is, it sent a SYN request. Now, the public IP, which is now going to be the source now, replied to my own IP. That is when the second handshake happened. Can you see a SYN and acknowledgement, right? Then the
Mm.
last one was when my IP now responded, okay, we can now connect. Then there was an acknowledgement. So you can now see client hello. That means it's saying we can now communicate.
Okay.
You understand? Just because
Yeah.
I visited that website.
Yeah.
Do you get that now? So this is
Yes.
just, yeah, so that's just
So when you
that.
do, what you refer to as network is, let's say, my Wi-Fi now. If there are so many
Mm,
devices, laptop, phone, and maybe my family's devices that are connected to that
yeah,
Wi-Fi
yes,
in-house, then I'll be able to
yes.
see the traffic going on each of those devices, if I'm correct, if
Yes,
that's what you meant.
once the wire, because Wireshark has different interface that you can actually check. So once you are checking
Okay.
the interface of that particular network that you are on, then to see everything that is on that network, all the traffic on that network. You understand? Because this is how they
Okay.
actually do investigations on network attacks, some network attacks. So when they leave this running, any investigation they want to do, it would have actually captured whatever. So you can see if assuming it was an attacker now that was trying to use this IP address to communicate, it will be doing funny things, sending files that normally the person that owns this PC is not supposed to be sending. When we
Yeah.
did manual configuration of IPs, the moment you configure IPs manually, then you realize that, okay, this particular IP address for this particular person's laptop or this particular person's device, right? So maybe
Yeah.
that IP address is doing something funny on that device, on that network, then you realize that there's something might actually be going wrong.
Okay.
You understand? I did not
Okay.
use TCP dump. TCP dump is also the same thing as Wireshark. It's just that one, the difference is that one is interface. So that one is
Okay.
command based. It's not an application. You understand?
Okay.
So if I try to do something like that now, if I say TCP dump, TCP dump dash I is the interface I want it to target. Target it's ETH 0. ETH 0 is Ethernet 0. Target ETH 0. Then the source IP. So let's say 127.0.0.1. Sorry, I'm not a sudo user. So it is listening now. Let's go and try and do, let's refresh this. Let me see if this is still. So can you see the difference between Kali or other operating systems ping versus Windows? You know, Windows after 4 it will stop, but this one will continue till I stop it.
Okay.
To never stop. The same thing goes for Kali too. If I ping something here, it will not stop. So let's go back and check if it has captured anything. Okay, it is still listening. Let's still do something else. Let me see. I go back and log in. This one is not loading. One is not loading. So let's go back and check again. Why is it still listening? Okay, the source. Okay, it's only 127 dots. Let's do something here then. Do something. Let's see. I think this interface is not active. Let me check what this one is thinking. Let's try 23 23.192.228.84. 192. The interface is not active. As you can see now, can you see it has started capturing? So it is the same thing with Wireshark. Wireshark is just the application. So this is my IP address communicating with another IP. So it's the same thing.